Hi, I am Athul Raghav Raj. I am currently doing my Masters in Electrical Engineering at University of Bologna. Today, I am here to present my research, and the research topic is improving power quality in a wind generation by reducing the curtailed wind energy through flywheel energy storage system and demand response. Going to the topic, what is renewable energy and why is it important? Renewable energy collects energy from renewable sources like solar, wind, geothermal, etc. And why is it important? Because it emits less carbon and other greenhouse gases. And it's a non-conventional source of energy, so it doesn't get depleted over time. So, using this renewable energy storage to meet the electricity demand will increase in the future scope. So, is it 100% efficient to install a renewable energy system? No, there are some issues associated with it. The main issues are the power quality issues like vulnerability, instability, and reliability. Consider the case of solar. During a sunny day, the power curve shows that it's smooth. During a cloudy day, it shows a fluctuation and spikes during the day. This causes uncertainties. And let's consider another case of wind. We can see that two timings in a year are considered, and the net load is varying from each other. This is due to the high wind integration at some time and low power. So, this wind, let's consider the case of wind. Wind power creates uncertainties and it causes instability. One of the main uncertainties in wind is the wind curtailment. So what is wind curtailment? Wind curtailment is the reduction in energy production. So how is it caused? It is caused when high wind speed is integrated into the system, and this creates imbalance in the system. So we need to sort this curtailment to improve the power quality and stability. So, studies show that adding flexibilities into the system reduces the curtailment. One of such flexibility is the demand response. Well, so what is demand response? Demand response is a strategy used by utilities to shift or reduce the total demand in a peak time to another peak of time. There are two types of demand responses, that are load shifting and peak shaving. In load shifting, the maximum demand in a peak hour is shifted to another peak of time. In the peak shaving, the maximum demand is reduced. That means some of the loads are reduced, and there's an effect or phenomena associated with this demand response. That is the demand response rebound effect. So what is this rebound effect? Rebound effect is when the delay or when we shifting demand from the peak time to the peak of time, the delayed demand creates some uncertainties or some spikes when it's shifted to the other time. Next we are going for the other flexibility, that is energy storage system, that reduces the curtailment. There are many energy storage systems that are mechanical and electrical. Mechanical storage includes compressed air, natural gas, flywheel energy, and so on. And in the electrical storage, there are batteries and ultra capacitors. These are used in transportation and in other backup facilities. So concerning the case of flywheel energy sources, we can see that the flywheel has the greatest efficiency versus lifetime in comparing with other storages. So the largest flywheel energy storage system is an EFDA jet fusion flywheel, and it has a energy capacity of 5555, and the rated power is 4 lakh, and the rated time is 50 seconds. So why has this flywheel got more efficiency, because in the flywheel there are two magnetic bearings used in the upper and lower. This creates frictionless and thus the friction rotational losses are reduced. This causes an increase in efficiency. So energy is stored in half I omega square. I is the inertia and omega is the angular momentum. So energy is equal to square of angular momentum. So my research is what is the change in the power quality and stability of a wind generation system by reducing the curtailed wind energy by the combination of flywheel energy storage system and demand response. In my design, I am combining the flywheel energy storage system and demand response to reduce the wind curtailment. Here, I used a simulation for the purpose. The simulation is used in MATLAB and mixed integer linear programming (MIP) is used. And the data for load and wind capacity are from Bonvilla Power Administration. The data are in 2013, and for the current demand we have increased 0.8% in the load and 20% in the wind capacities. Here we are concerned a unique approach for demand response. In this demand response, we are controlling the demand response and also the rebound effect. So here we set the demand response is set more than the expected load, and this aligns the rebound effect with the time of high wind integration. We can see that this green line shows the integration of demand response and rebound effect that aligns with the load. So this creates more reduction in curtailed wind energy. In the graph, when it's 12.5% of DR, it's 941 is the curtailed wind energy. It gets reduced to 878 when the demand response is 10%. So the combination of demand response and mechanical storage, like the case of CA, is considered in this. Like the combination of CAs and the demand response give a efficiency or reduction in curtailed wind energy by 40%. Here we can see that the curtailed wind energy was 939 when battery storage is used, and the combination of demand response plus a mechanical storage, that is CAs, we can get a reduction by 624, and there is a reduction in the gas by 271. We know that by this, while we go through the flywheel storage, we have seen that flywheel has more efficiency, and the flywheel has short time of charge and discharge time. And a simulation is performed when without and with a flywheel integrated system in a wind is used with 350 kilowatt of load is increased. The simulation result is, we can see that without the use of FESS, that is flywheel energy storage system, the system frequency is fluctuating and it's underdamped. And when we, with the integration of FESS, we can see that the demand of the system frequency is just underdamped and it's stable. This reduces the uncertainty, and it will improve the power quality and power stability. So the advantages of this is FES requires small area compared to CAS, and the FES operates at almost frictionless. I also mentioned about the magnetic bearings, and FES has an efficiency of 80 to 85%. The disadvantage is that the consumers has to adjust with the load reduction by the utilities, and this cannot be used in large scale. The main disadvantage of FES is the low duration time of FCS at rated power. This concludes my presentation. Thank you.